Hello there guys, and welcome back to another epic and extra maths video. In this video we're taking a look at how we're going to differentiate x squared, but from first principles. So what this means is we know how to differentiate x squared, or we should do, or if you don't, it's fine, it's very easy, right? The derivative of x squared is 2x to the power of 1. We know that, most of us will. You can use this power rule where you just times the coefficient of the thing that you're that you're differentiating. So for example, this is 1x squared, isn't it? It's 1 lot of x squared. So you do 1 times 2, because 2 is the power, that gives you 2. And then you just reduce that power by 1. So you get 2x to the 1, or just 2x. But where does that actually come from? And if you're doing something like A-level maths, there's exam questions that will ask you to do this. So it's quite good to actually do it from first principles. So what that means is by using the definition of differentiation, the definition. So remember, and we do have a video on this, the definition of the derivative of a function, we use this notation f prime of x, it's kind of an apostrophe. That means the derivative of f of x. That is equal to the limit as h approaches 0 of f of x plus h minus f of x divided by h. I've got an entire video explaining that formula if you're not happy with it. But we're going to use this formula as a given. As I say, I've got a video deriving it, which I'll put a link to in the description. But we're going to use this formula in this video as a given. So we're going to define f of x to be x squared. And we want to find f prime of x. We want to find f apostrophe of x, the derivative. That's what we're doing. We're trying to differentiate this bad boy. So how do we do it? Well, we simply use the formula. So we can say that the derivative, we don't know what it is yet. Well, we do technically. It's 2x, but we want to show it. So let's pretend we don't know what it is. The derivative of our f of x, the derivative of our x squared, must be equal to the limit as h approaches 0. H is just kind of like this arbitrary little variable that we let get very, very small, of f of x plus h. Now, this is where most people go wrong. What f of x plus h means is, whenever you see an x in your f of x, replace that x with an x plus h. It's the same as normal function notation. So it's like f of x. If you see, if you have f of 2, replace every time you see an x with a 2. So for example, in this case, f of 2 would be 2 squared, which would be 4, and so on, right? It works the same way. F of x plus h just means replace your x with an x plus h. So x plus h here, well, there's an x there, isn't there? Because it's x squared. So we are going to replace our f of x with f of x plus h. So that's going to give us x plus h squared. Do you see that? You see this similarity here? You go from x squared to x plus h squared because we replace the x's with x plus h's. That's the idea, okay? So that's the first part. And then we simply take away f of x. That part's not too bad because we know what f of x is. It's x squared. So there we go. And then we have to divide everything by h. Okay, we divide by h. Awesome. So this is what we've got so far. This is everything plugged in. Now we just need to evaluate this limit. How do we do that? Well, let's try expanding out the brackets. So it's important, especially if you're in an exam situation. You might not be doing an exam, you might just want to know this, but if you are in an exam, or you just want to be very formal with your mathematics, always write limit as h approaches 0 after every single line, because it's really important to show the limiting process. We're now going to expand these brackets, x plus h squared. That will give us x squared plus 2xh plus h squared. That's just that bracket expanded. And then we take away the x squared because there was also an x squared at the end there that needs to be taken away. I expanded that bracket quite quickly. If you're confused why that's the expanded version, just use FOIL. So x plus h times x plus h, expand out like so, and you will get that, I promise you. Divide it by h, okay, because it's still there. All right, moving down again. I'll zoom in a little bit actually. Awesome. Okay. We now take the limit. Remember to keep writing limit. It's very important as h approaches 0. Now what we can do here is we can actually simplify this thing by a little bit. Because notice how we have an x squared minus x squared. Those two will cancel out. And what we get left with is simply 2xh plus h squared, and we're still dividing by h. That's still there. Awesome. Now this is much simpler, because now what we can do is notice how every term here in the numerator and denominator is a multiple of h, which means what we can now do is divide the top and the bottom of the fraction by h. So we get 2x plus, actually I'll write that a little bit lower, 2, and I'll put some brackets around it because why not, 2x plus h, just like that. Because notice how that h, one of these h's, so that's just a h to the 1, and that h all cancel out, and we get 2x plus h to the 1, 2x plus h. Okay? And we get this. And now, this is really easy to take the limit of, isn't it? The whole limit thing, what's the limit? What is that? It simply means what happens to this whole thing when h gets really small. The issue is we can only evaluate it at this point. We couldn't have done it previously because we'd be dividing by h. And what happens when you divide by 0, because h is approaching 0? Well, you get a big problem. But now, we don't need to divide by 0, because h is just being added, which is really good. So now we actually take the limit, we don't need to write limit anymore. And what happens when h approaches 0 in this expression? What happens when h gets closer and closer and closer to 0 in that expression, 2x plus h? Well, 2x plus something that gets smaller and smaller and smaller and smaller, it just turns into 2x. And you don't need to worry about h anymore, because h is absolutely negligible. It's approaching 0. It's becoming infinitely small. We don't need to worry about it anymore. So it's just equal to 2x on its own, because the plus h doesn't matter anymore, because it's infinitely close to 0. And what we've just said is that the derivative of our function, which was x squared, is equal to 2x, and that is how you do it. Thank you guys so much for watching. I highly appreciate it, and I'll see you in the next video. Cheers.